Alright, let's go ahead and discuss this homework. This is obviously 1 through 6. This is fairly easy, meaning you don't have to really figure stuff out, do a lot of processing skills. This is more of a instant recall or memory type question. Alright, so it says for each science describe their model and or experiment, the information learned and what they contributed to the atomic model accepted today. Then it says draw their model of the atom. Okay, so this is just the history lessons that we gave you in the notes in the first little while. Let me pause this and I'll open some. Alright, so we'll go ahead and just look here in a second. But all we have to do is draw their model or talk about their experiment and what we learned. Alright, so the first one's Democritus. If we look in our notes, this what is an atom? We'll go ahead. We talked. The first thing was about Democritus, a Greek philosopher, came up with the idea of the atom by thinking about it. Democritus' hypothesis was that all things were made up of small indivisible particles, which he called atoms. Alright, and then we had this. And that's the picture of his model of the atom. He didn't do an experiment. All he came up with was the idea that the atom did exist. Alright, so we'll go ahead. Let's draw his model. It's just a circle. Really simple. Alright, and then I would say came up with idea of atoms. So he's the first one, at least that in recorded history, that thought, hey, what is stuff made out of? Alright, this stuff that I'm sitting on like a rock, it has parts. We're going to say the fundamental part of this is called the atom, and that fundamentally it was not divisible, meaning you could not break it apart. Okay, the next model is Dalton. It looks kind of similar. We're going to kind of skip that. You can look at Dalton, but let's talk about Thompson. Thompson came up with a model. Alright, so Thompson, he had a model that was based off his experiments. Let's go find his real quick. Here we go. Well, there's Dalton. You can read Dalton in your notes, and all these are right in your notes. Oh, hey, there's Dalton's model. Alright, now let's come up with Thompson. Where on earth? Oh, I just barely went past it. Okay. Oh, one more. J.J. Thompson developed his model of the atom when he discovered that atoms are divisible. Alright, so there's a big jump. He used the cathode ray tube and used that to excite the atom, get electrons to come off. He didn't know they were electrons yet, but to shoot these things through a beam and they were deflected. That's what this picture is talking about. You can see the deflection area right here. Alright, I can't draw on this one like I can the other one. Maybe I can. Alright, looks like I cannot draw on it, and I thought I'd be able to. Anyway, he came up with this cathode ray tube experiment where he discovered that electrons come from the atom. Alright, that must mean that they are divisible. Alright, he's going to come up with his model. We'll see that next in the notes. We call that the Plum pudding model. Now you've already probably done this homework, but so for Dalton, you can do that on your own. Thompson, we need to draw his experiment. So it's a cathode ray tube. Alright, he had a plus, he had a minus. He shot things through here and they bent towards the positive away from the negative. Alright, he assumed then that whatever these were, they were negative, and he called them electrons. Alright, so there's his model, or sorry, his experiment. His model, the Plum pudding model, had the plums that were negatively charged and a positive goo that surrounded it. I don't know if I said the plums were negatively charged yet, but they were. Alright, and then we would say discovered electron, and that would be adequate for that. Alright, for each one of these, we need to draw, if there was an experiment, we need to, so that's what this was. We need to draw what their model is, and we need to draw or tell what we found from it. Okay, those are easy enough.